ahead of time, and I can now walk through using the spatial autocorrelation tool to choose the best radius for my point density analysis. We're going to point the tool at those aggregated 911 calls and use the count as our input field. Now we have to choose a conceptualization of spatial relationships. There's also great documentation about choosing the right conceptualization found in the desktop help. But as a general rule, with point data in a density analysis, you'll probably want to choose either the fixed distance band or the zone of indifference. Here, I'm going to use the fixed distance band. The next thing that we want to do is choose a fixed distance. Now for the fixed distance band, we can start with the smallest distance that is still at a scale that we're interested in. Let's say 2,000 feet in this case. Again, this is where you really have to think about the questions that you're asking. When I run the tool using that distance of 2,000 feet, it returns to me a z-score, which in this case is 5.41. Remember, that z-score is measuring how intense the clustering is for our selected distance. I've already run this tool 13 times. I used 1,000 foot intervals up until I got to 15,000 feet. I chose 15,000 feet as my cutoff because after that I thought that the subtle neighborhood patterns that I'm interested in would be lost. I know that may sound a little tedious, but it runs really quickly and the result is definitely worth it. I put each distance and z-value in a table and added that table to ArcMap. I then graphed the z-scores, which we can see right here. The graph shows us the global z-score values for 13 different distance bands. And we have a peak right here at 8,000 feet. So now we can choose a radius parameter by letting the data help us, and we no longer have to use the default value for the point density tool. We can use our peak, which in this case was 8,000 feet.